One more option of sample preparation, and very popular one, is solid phase extraction. Solid phase extraction works nicely for most of toxicology samples, and it's easily automated. Just some examples of cartridges. These cartridges can be attached to usual syringe and can be of very different size. One more example is a filter that can be used for filtration, or alternatively, solid phase extraction material can be placed inside. So how does it work? First, cartridge need to be conditioned. Usual conditioned solvent is methanol followed by water. So the sorbent is wet and it's hydrated. Next, we apply our very complex mixture containing our desired analyte and lots of different compounds. As a result, most of our mixture is sitting on the column. Some of components will pass through. Say, if we're doing from water, usually it will be sugars, simple proteins, sodium chloride, so on. Now, we apply additional solvent. This is an optional step to remove some of interfering analytes, this black triangle. Next step, we apply stronger solvent that will remove our desired analyte. Some contamination will still stay, for example, some particulate matter, polymer material, and so on. So we are collecting this fraction and processing it later. Similar picture, just different schematic. First, of course, is conditioning with methanol water. Then we apply the sample. Sample is sitting on a column. Some of interfering compounds that are soluble in our starting solvent will pass through. Next, we are washing out contaminating compounds, and then we elute our analyte. Alternatively, we can run our sample application same way as we did, and instead of washing out, just elute our analyte, and interfering compound will mainly stay on the column. There are plenty of options of doing the same thing. Again, this can be easily automated. So what's inside the cartridge? How our compound can be retained? One option is non-polar surface. So our extracting compound will be carbon 18 tail bound to silica. So you see CH2, 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 CH2 groups, and these groups will interact with organic compounds that will stick to it in aqueous solution. Now, if we add organic solution, these compounds can be dissolved and can be washed out. There are different ways to force our solvent through the cartridge. One of them is simply push it through the syringe, so applying pressure by syringe. Another is negative pressure, putting our cartridge in its centrifuge, so the solvent will be pushed through the cartridge by brutal force with hundreds of G. One more alternative, simply applying vacuum filtration, exactly like we did for usual filtration. Sometimes you need additional pressure here so you can wash your solution through the usual filtration flask. Again, applying vacuum here. So this is one example of how it's helpful. Here we want to look at naproxen determination, and we are using nitrobenzene internal standard for determination. So in this starting with no cleanup, just bulk sample loaded into our instrument, we see internal standard of nitrobenzene. But we do not see our naproxen that should be somewhere here, and here we have a mass of peaks. The second picture presents the same system after solid phase extraction cleanup. Our nitrobenzene stayed the same, but most of proteins are removed from our mixture, so naproxen peak is easily visible. Here it's hidden somewhere in this messy picture. So you can measure intensity of this peak compared to your internal standard and have your results ready.